Come on, Spilly. Oh, yeah. I don't mind this thing. Yeah. Just checking.
Yeah.
Oh. Damn it.
Okay, this is the start button for the laser maze. And this is a lit button, so I have 2 wires going to it for the light, and then there's 2 wires obviously for the switch. And then this is going to start the sequence for turning on the lasers and beginning the game. And this is the stop button for the game. Again, I can control the light flashing on this, or have it solid flashing. And when this button is pushed, then you're successful through the laser maze, and then I play some music and then flash a light. This is one of the green lasers mounted to the wall. At first, I was going to try to mount this a little bit differently, but they have to be very solid. If they move at all, the lasers miss the photo sensors, and the whole thing is not going to work. So the most critical thing is mounting this firmly, and I've just used some hot glue onto this bracket. I put the laser into this tubing, so I have some adjustment. If I have just some very fine adjustment I want to do, I can change these screws and just change the position of the beam a little bit without having to remount the laser to the wall. Originally I was going to do 10 lasers and 10 photocells, but I had trouble getting good quality green lasers, so I ended up just having 2 out of a batch of 12 that I ordered that worked well, and I decided then to bounce the beam off mirrors instead. This is one of the mirrors. It's actually fairly large. It turns out that that's probably a good thing to have the larger mirrors. Makes it easier to bounce the beam. I was bouncing it about 4 or 5 times. So after a while, if you have small mirrors, you're going to have trouble aligning all of them to the sensor. There's another mirror down here. This is one of the photo sensors. It's just a CDS cell that I kind of glued into this plumbing fitting here. And photo sensor is really just a resistor. It changes resistance with light. And I guess the critical thing here is just aligning the whole thing and getting it to not move over time. My constant struggle was, as the temperatures changed, just slight changes, the beams would sometimes miss the photocell. Now luckily, when I bounce it a few times off mirrors, the beam gets a little bit wider, and that actually helps in aligning it to this sensor. Okay, this is the laser maze controller that I built. So I just built this little wooden box. Actually decided to put a little fan on it just to keep things cool inside. And on the front is a counter. This counter is kind of cheap, and I kind of struggled with this, so I ended up not using it this Halloween. Kind of optional. I don't really know if people really care to time themselves through the laser maze or not. Maybe next year I'll try to replace this one with a better one. And then there's the flashing light and the 2 speakers for my music and my sound effects. Alright, so inside the box, let's just do that. Okay, so there's the electronics with the counter, although as I said, it doesn't work very well. Again, I'm using a Fright Props BooBox FlexMax controller. Could be done with an Arduino, but I didn't want to spend the time having to worry about coding and figuring that out. So the controller is just really simple. There's 8 inputs and 8 outputs on this one. The inputs are the start switch, the stop switch, and the photo cells, 2 photo cells. The outputs are turning the lasers on, turning on the counter. Inside the controller has got built-in the ability to play music and sound effects. And all of this is really just the electronics. This breadboard, the key to this is the chip. This is a quad comparator chip, and this is for the photocell. So when the light hits the photocell, it changes the resistance, and that therefore changes the voltage into the comparator. And when the voltage exceeds the base voltage that I'm giving it, then it triggers the output of this chip to activate one of the relays. And then when the relay is activated, you can turn on lasers, or you can send a signal to the controller. So this whole circuit, really the success of this is just built around this quad comparator chip. The resistors are really just to get to the desired voltages to make sure the sensitivity of the controller is enough to trigger the chip. So I changed the resistances enough, kind of playing around, a little trial and error to get the voltages right. And then these relay boards, I guess a lot of people with building Arduinos and using these kinds of circuits, you can readily get these relay boards. These are for 5 to 12 volt. I used a 12 volt throughout my my box here. The 12 volts drives the boo box, and the 12 volts drives the relay. So it's just kind of convenient to use one power supply. So there's the power supply driving the boo box controller, and then this is the power supply that I used to drive the lasers. That's only 3 volts for the green lasers. And then I had this override switch, so here you can turn the lasers on manually if you're going to just align everything up. The other thing I did with the relays, so I wanted to have it when you break the beam of the laser, that everything shuts off right away for safety. So I used a latching relay circuit. So once the relays turn on, the light hits the photocell and it kind of keeps the relay turned on. As soon as the light beam is broken, the relay turns off, and you really need to send an external trigger to that relay to start that latching relay to working again. So it's a nice way to guarantee that there's not going to be any safety issues. And then, of course, just a power bar for all the power supplies. This power supply is for the flashing light that I use there. And that's pretty much it. I started working on this 2 months before Halloween, and most of the time, honestly, is spent just kind of figuring out the lasers. Okay, these are some of the different lasers I was trying. Originally, I wasn't sure if I can go with a red laser or green, and the red lasers are definitely cheaper and readily available. They're probably 10 times cheaper than these green lasers. The problem is the red laser light, it's just not visible enough. So you want to use a 5 milliwatt or lower powered laser. You don't want to have too powerful. You got to keep laser safety in mind. And certainly someone looking at these, if you're too powerful a beam, anything over about 5 milliwatts, you're going to risk hurting people's eyes. So these red lasers, I bought I think a pack of 10, and although the beam actually looks bright here, in reality, in the garage with the smoke effects, it's quite hard to see the red. I think the human eye is just more attuned to the green laser. And so the green laser really is more accessible to buy as actual laser pens. Or if you do buy the modules, sometimes you get something like this, or sometimes the module is taken out, but it's just not as compact as the red laser, which is here. So it's a little bit more difficult to work with. The other thing I found is, by just buying these laser pens, the beam is not always the same brightness. It sometimes fades or gets, some of them didn't even work. So the real challenge is getting as good quality working lasers and making sure you're getting a 5 milliwatt or 3 milliwatt, and certainly nothing more powerful than that. So when I use mine, I had to obviously hook up an external power supply. So I just soldered some wires to the spring and the edge of the casing. So I get my wires coming out there. Then now I can control and turn that off with my prop controller. Okay, this is the schematic I have for my breadboard. And the breadboard looks more complicated because I have it wired for 10 lasers, but I ended up only using 2. So it really starts with this LM339 chip. This chip has 4 of these comparator circuits in it. I'm only using 2 for 2 lasers, 2 photocells. And if you wanted to use 4, you could use all 4 of these for 4 photocells. And if you wanted more, you could add more chips if you wanted to use more lasers and more photocells. How this works really is when the light's hitting the photocell, it's going to change the voltage going into the input. and the difference between the voltages in input 1 and input -1 determines whether this circuit's going to switch and give you a voltage to the output. And when that voltage comes out of the output, it goes into this relay here, and relay E and F will both be turned on when both photocells are hit by light. And that in turn goes over here to this relay circuit, and then that information gets back to the BooBox controller that the photocells are active. Now the BooBox, it's not controlling directly. If the laser beam is broken, there's a latching relay circuit that's being used over here, and this circuit will just turn the lasers off automatically before even telling the BooBox that the circuit's broken. So I did that just for safety, and then to reset the lasers, the BooBox will turn relay A on, and it'll kind of just reset the circuit again. So I'm not going to explain any more detail than that really. This is the circuit, and the key components, of course, are the relays that I have, the quad comparator, and of course the BooBox controller. Okay, this is the director software that comes with the Fright Props BooBox controller. There are several scenes you can program. These are all the different scenes. I've got some ambient scenes that just play sound effects and music until someone's actually started the game, just to keep things interesting. And then I'm using a few of the inputs here, these different scenes. And on the left side, these are all the different outputs of the BooBox controller. So we got the flashing light, the timer and timer reset, the stop and start buttons. And these outputs are actually the lights inside the buttons. And then this turns the laser on, output number 6, and output number 7 turns the lasers off. So the game starts when input 4, the start button, is pressed, that green button. Then it starts playing this scene, and this scene actually all it does is no sound effects. It just turns the lasers on, and then the latching relays will keep the lasers on until the beam is broken. After this scene, it goes to input 1. And that's kind of the main scene. This plays the Mission Impossible music, and we start the timer incrementing numbers. We also start flashing the stop button. The red button will flash every time this blue is shown here on the timeline is when the light will turn on. And so as you get near the end of just over 60 seconds and the music is over, that scene finishes. So if you haven't hit the stop button by then, the game will give you the message that you've failed, and that's scene number 2 here. So when I play this,
they're dead. My team is dead.
And you can see that the team is dead and they failed. But if you get to the stop button and push, it plays the sequence for success, and then it also just turns the lasers off. Since you haven't broken the beam, I got to make sure to keep the lasers off. And that's pretty much it. So it's very easy to use software, very configurable. You don't have to worry about programming an Arduino if you want to go down that path. And that's it for my demonstration.